Hi everyone, Brenda Guston here, and I want to show you how we did the experiment that you're going to analyze the data for in this section of the lab. I have three different kinds of media here, and one is nutrient agar, one is saboride agar, and the third one is EMB agar, eosin methylene blue. Recall that nutrient agar is a general purpose medium where most of the organisms that will grow on media will be able to grow on nutrient agar, not all, but most of them. Saboride is selective because it discourages the growth of bacteria, but encourages the growth of fungi. So remember, the fungi are the yeasts and the molds. It doesn't mean bacteria can't grow on this, but it's just, it selects for it, favors the growth of fungi. And you might recall that's because it has a little bit of a low pH and a little bit of a high amount of glucose. It's a little bit hypertonic, which are conditions under which fungi prefer. The last one, EMB, eosin methylene blue, is selective and differential. It contains some components, particularly BIOL, that and methylene blue, that cause this to be selective for intestinal bacteria, particularly fecal bacteria. And it's differential because it contains a dye called eosin, and eosin turns metallic green when E. coli grows on it. So it's selective and differential, and this was developed in order to quickly identify E. coli. So what we're doing in this experiment is we are sampling three environments. One is the dust on the air vents, so behind where you can't see, there's some air vents in the room, and lots of dust settles there. Lots of air's moving around, and lots of dust settles there. And the other place is my hand, and the third place is the bottom of my foot. And what we did is I got a bunch of people to do this experiment, and we put those samples on these three different kinds of media to see what would grow. And let me show you how we did that. We have sterile swabs, and I'm going to open that up and take out one swab, try not to touch the others, and carefully replace the lid. Remember, with things like this, for good aseptic technique, I'm going to open it up and I'm going to close it as quickly as I can because air goes in there and dust goes in there. We don't want to contaminate those. The other thing I have here is some sterile water, and I'm going to unscrew that. And remember, it's just easier to pick up dirt or something from a surface with a wet cloth than it is to pick it up with a dry cloth. So that's the only reason why I'm moistening my swab, is just to pick up more microbes. And I'm just going to squeeze out a little bit of the water on the inside. And again, because I want this water to remain sterile, I'm going to close it right back up. So here I have a saboride plate, and notice that I labeled it that it's saboride agar. I put my initials on it, and actually you should also write on it what your surface is. So let's say on this case I'm going to sample the surface of my hand, so I would write that on there. So I'm going to put the plate down, and next thing I'm going to do, and notice I put the plate down with the lid down. And there's a reason for that. I'll show you that in a second. And so I'm going to take the surface of my hand with my wet swab, and I'm just going to kind of go back and forth and swab the surface of my hand. And then I'm going to pick up the bottom of the plate. Now, if I can pick up the bottom of the plate, I can start to spread this on here. If I had my bottom down, I'd have to pick up the lid, put it down, pick up this, do a little twist. It's a lot more manipulations, and when you're doing a lot of plates, it turns out to be a big deal. So I'm going to pick up the bottom of the plate, and I'm just going to start at the top, and I'm going to swab from top to bottom. And hopefully I'm spreading some bacteria all over this plate. I'm going to turn it 90 degrees, and I'm going to swab again. Now, using good aseptic technique like you would do in a clinical setting or in a lab setting, I want to make sure I'm not facing it at me. I want to make sure I'm not talking on it, because I can spray aerosols and other bacteria. I'm going to close this right away when I'm done. And I have a discard for my swabs. And I'm going to do that on each of these plates. So 3 of them I'm going to put skin bacteria. 3 of them I'm going to put swabs from dusty areas, and 3 of them I'm going to put a swab from the bottom of my foot. We're going to incubate these for a couple of days and see what grows. In the second part of this experiment, I'm going to use my trusty assistant to give me some more samples. The question I was wondering is, will the bottom of my dog's foot have microorganisms that are more similar to those on my skin, those in dust, or those found on the bottom of my shoe? And so I'm going to do the same thing. I'm going to take a sterile swab. Oh, there we go. And some water. Oh, here she just woke up. I'm going to get some water. I'm going to moisten it. And this is my dog, Jeanette. Jeanette, say hi. Say hi. And I'm going to take her paw, and we're just going to swab it. You like being an experimental dog? No nose prints. There we go. Thank you, Jeanette. And I'm just going to take a plate like I did last time, and I'm going to swab. Don't put your nose in there. That'll make it not sterile. And swab again. So what do you think? Do you think the bottom of Jeanette's foot's going to look more like the bottom of my shoe, dust, or my skin? Wait, look at the results and you'll see.